So for quite a while now, I've been wanting to build a hovercraft, and although hovercrafts aren't anything new online, you can search it and you'll find many other people that have built hovercrafts. I want to try and put my own little twist on it. You see, a lot of my projects are based around using a 3D printer to experiment and produce certain projects. For example, my 3D printed plane, which I did quite a while ago. That was completely impractical for a remote control plane. Second, my compressed air engine. I didn't need a 3D printer to produce that. I could have got it manufactured using injection moulding. However, I'm going to put a little twist on this hovercraft, and I think that 3D printing is possibly the best way of manufacturing this. And I'm going to show you why. The design I've chosen to go for is a single motor hovercraft. This is to keep the hovercraft as lightweight and as simple as possible, as well as keeping the cost down. Just under half the thrust produced by this motor is directed through ducts and out the bottom of the hovercraft to produce the lift. Now, this design of hovercraft isn't anything new. However, I chose this design because I think it really displays how well 3D printing is suited to this design. Now, as I want this hovercraft to be pretty small and pretty easy to make, I want it to be manufactured as one piece. Now, to manufacture this hovercraft in one piece using any other manufacturing technique other than 3D printing will be quite difficult due to the ducts having to be hollow. I'm sure you could injection mould it in a few different parts and then glue it together, or sculpt the whole thing out of foam. However, 3D printing can manufacture it all in one piece. Now, not only did I want to be able to 3D print the whole frame in one piece, I also wanted it to be printable without support. Now, inside of these hollow ducts, there is a large overhang, so I designed two fins inside of the ducts, which shorten the overhang from 17mm to only 5mm, and this seemed to work out pretty well. The motor and propeller housing was printed as a separate piece because there was no way that I could design this into the main frame and still have it printed without any support. Plus, it also allows a different colour to be chosen, which makes the hovercraft look a bit better. So everything is finished printing. In the blue is the main chassis of the hovercraft, which is by far the most hardest part and also longest part to print. In the red, there is the skirt clamp, which will clamp the skirt to the bottom of the hovercraft chassis. And also here is the rudder and the motor mount / propeller housing. So let's take a quick look at the main chassis of the hovercraft. The overhang bits inside here turn out really nicely. I just blasted a hot air gun through there and also up through the bottom here, just to clear all the stringing so that there was a free channel for the air to flow through once the hovercraft is finished. The other bit I was worried about was this little overhang here, and it seemed to turn out pretty nicely. Obviously when it's printed with this being at the top, this is almost like an arch, so I don't know if you can see the filament did sag a little bit, but it's only an aesthetic issue. It doesn't do anything important. Taking a look at the underside, all of the channels where the air comes through look really nice. The channels for where the wires will go through as well as the receiver and regulator sort of hatch at the front here. Everything seems to turn out pretty nicely. The other 3D printed parts in red turned out really nicely. This is the motor / propeller housing. It's a pretty simple print. I printed it this way up, so there's no overhangs. And yeah, I did have some stringing as well in here, just blasted it with a heat gun and it's sorted. The other two prints are pretty straightforward. So let's start by mounting the rudder servo, or the servo that will eventually steer the hovercraft. So the wire should just pull through and then the servo will slot into this little gap at the back here. Now, just before I bolt this servo down properly, I've noticed that the wire that comes with this servo is slightly too short to reach the small hatch at the front where the receiver will mount. Now, this could be solved with a small servo extension, but I don't really like using big servo plugs and extensions, so what I'm going to do is take the servo out and replace the wire with a slightly longer custom wire. Now I'm going to move this aside and going to work on the motor mount / motor housing. Now I'm using a very small 1407 2300 kV electric motor, brushless motor. This is actually one that I stole off of my old SpaceX rocket model. So I'm trying to recycle all the parts here. The wires should thread down through this vertical section, and then the motor will just mount on the back here with 4 bolts. I think what I'll do first though is mount the propeller, just because it's harder, it's easier to get to when it's not inside the housing. This is a 3-inch propeller, a 3-inch tri-blade, bullnose propeller they're called. The reason why I picked this propeller is when it's inside the duct, it's as close to an electric ducted fan blade as possible. The reason why I want it similar to an electric ducted fan propeller is that I think it will give me the most amount of thrust possible for this size, at least for this diameter of propeller. So let's just thread that through and remount it. So I haven't tightened up the bolts completely. I want to see how well this works through the housing. Right, that does not fit at all. So yeah, you almost have to tighten these in a pattern like you would on a cylinder head of like an engine, so that they all equally tighten at the same rate. This way the motor is perfectly square with the motor mount, and the propeller should spin without touching the housing. So yeah, that's nice and smooth now. So the mounting mechanism that I've designed to mount this motor housing and motor mount to the chassis is actually quite interesting. I've designed it so that one bolt can be used to mount this side of the servo and also mount the whole motor housing. This will now slot, see that slot in the back of the motor mount? That will line up with the servo and holds it flush. Then under here, a bolt will go through that smaller hole there, and that will go all the way up through the servo hole there, if you can see that, and then mount everything together. So it will hold all of that thing in, all of that section in one piece. Now there's one issue right now, and that is that this bolt to hold everything onto here is a 30mm long M3 bolt, and the post is being really slow around where I live at the moment, so I'm going to have to use a 20mm bolt, which isn't quite long enough to clamp it down, but it will hold it in position for now. Yeah, everything fits together pretty nicely so far. I'm really happy with that. Now it's time to solder up the speed controller, which will power the motor, and this will sit right here in this small slot. Now I've tried to push it in as far that way as possible, so that when I look from the side it's flush and it's not going to hit anything on the ground. Now the wires at the other end of the speed controller are the main power wires, and they will thread through this small slot in the top of the hovercraft, and then I'll need to solder a battery connector onto the other side. So the speed controller is now mounted nicely on the underside of the hovercraft chassis, and it's inside the airflow for the lift direction airflow, so it's basically being force cooled, which is quite nice. Now I'm going to wire up all of the wires to the front of the hovercraft and solder up the receiver. Now I think this should fit fine without the servo pins removed. However, seeing as I've got no servo plugs on here anyway, I'm just going to desolder all of the pins so that I can solder them all directly onto it. So all the electronics are nice and neatly installed. From the top you can't see any electronics, or any wires at least, apart from this main power wire, which you'll have to see because the battery mount's here. But all the rest of the wires are nice and neatly installed. Now, as you just saw, the 5-volt regulator is flapping about a bit, and this won't be an issue once I mount the skirt, and I'll show you why. The clamp, or the skirt clamp I call it, which will hold the skirt to the main chassis of the hovercraft, will have this cover, and it will cover the receiver and the 5-volt regulator, protecting it from anything that I'll drive over. So I'm waiting for the bolts, which will go around here, which will clamp the skirt. They're still in the post, but no, I'm pretty happy with that so far. Right, so here's the rudder, and here is one of the servo horns which come with the servo, and it's designed so that that just press fits in there, and then that press fits onto the servo. So yeah, that's the steering rudder and the... Right, so I'm going to call that a day, and hopefully the post arrives with all my parts tomorrow, and we can finish the rest of this hovercraft. So the post has now arrived with all the required hardware that I was waiting for. This includes the M3 by 30mm countersunk bolts, or bolts that I need to secure this motor housing down properly, and also the M3 by 6mm countersunk bolts, which I'll use to clamp the skirt to the bottom of the frame using this. Now in terms of skirt material, there's quite a few different things that you could use. I want to use something quite durable, but to start off with, I'm just going to use a regular bin bag, just bin bag plastic. The reason why is that I need to do some prototyping of what size and shape skirt I'm going to use, because the skirt design on a hovercraft is normally the most complex part, so I don't really want to be wasting expensive ripstop nylon material. So because earlier we printed out the skirt clamp, which is going to clamp it to the bottom of the frame, I'm going to use this as a sort of a stencil or something to trace around to cut out the skirt. So I'm not really sure how big I need to trace around the outside of the shape of the hovercraft. So I'm just going to sort of do it roughly and test it. Because the bin bag material is so cheap, it's not really an issue if I get it wrong, it's just a bit of a waste of time. So just sort of do it by eye for the moment, I think. Now what I'm going to do is I'm going to put double-sided sticky tape around here just to secure the skirt. I'm going to fold it up like that and stick it down, and then we'll bolt it to the actual frame. So I've finished putting the double-sided sticky tape tabs around the edge of the skirt clamp, and I'm just going to fold over the edges, I guess. Now this is going to be the awkward bit, trying to wrap the front section. It's a bit rough, but got to test it out. Now these corners would also be quite awkward, but if you're good at wrapping Christmas presents, then you might be alright at this. Okay, so that should be good enough. There are some gaps, like in the corner here, but once it's all bolted to the main frame, then it shouldn't be an issue. So let's put this like that, and position it, and find where all the bolts are. Right, so I've got the skirt all fully mounted, and I can't seem to see any gaps around the edge of the bag, so it's time to give it a quick test hover. I've got the fully charged battery here, and I'm just going to Velcro it, probably somewhere in the middle, and got my remote control turned on, and let's plug it in and put it over here just in case it does move, and increase the throttle. That's really good, actually. Okay, so it hovers at probably about 25% throttle. It hovers, so that's quite low throttle setting. Okay, did you see that? It sort of tilted over to one side a bit. Now, let's just try that again. If I hover it and... So the skirt design that I've chosen for this hovercraft is probably one of the simplest types of skirts to build. It's a C shape skirt, I believe it's called, where it has like a C profile shape to the skirt around the edge of the frame. Now, although this skirt's really easy to make, I've read up that it's quite unstable for hovercrafts that aren't circular, because this section around here has an uneven tension on the straight sides, which I think is what causes it to, you know, sort of dip to one side. Now, the alternative skirt, which the majority of people use when they design remote control hovercrafts, is I think called a vented bag skirt. So what they do is they actually fix the skirt, the inner part of the skirt, to the bottom of the body, and this prevents these sides from lifting up. So what I'm going to do is I'm going to tape down these sides and just give it a quick test like that and see if it prevents it from tipping to one side. I think this might also limit the ride height of the hovercraft, but it's quite high already, so it's not an issue if it's just a bit lower, I think. Now, normally when you have a vented bag style sort of skirt, it will be sealed all the way around the edges, but just little holes. However, I'm just going to put a bit of tape here just to quickly test it. So it still hovers. Seems to hover quite a bit lower this time. It didn't dip then on the high throttle setting. Let's try that again. Yeah, so that seems to perform quite a bit better. I might even add a little tab at the front and the rear. So it seems to work quite well. What I'm going to do is I'm going to head inside and find a larger floor to test it on rather than this small bench, and see how well it steers. Let's go. Initially, I was quite happy with the Hovercraft. However, after a few minutes, I did realise that there was a control issue. Now yes, I realise that hovercrafts are not the easiest vehicles to control. However, even after quite a bit of practice, I couldn't help but crash into the wall. Now probably the best way to show you that there was a lack of steering authority is by putting it into a harsh left-hand spin. Here you can see when I want to exit the left-hand spin, I apply full right rudder and it takes forever for the hovercraft to actually turn right. So after those first few tests, the single rudder didn't seem adequate enough. As you can see, it can rotate about 40 degrees, 45 degrees. And I know most remote control hovercrafts use dual rudder. However, it's not going to be easy to modify this design. For example, I'd need to move the servo somewhere else and put a pivot point here and here, and linkages, and I'm not prepared to redesign the whole rear side of this just yet. Now I've come up with a simple solution which I think will solve my issue of the single rudder steering authority, and that is to use a different shaped rudder. Now this rudder is shaped, well, it's like a weird triangular shape, and let me just mount this on the hovercraft and I'll show you a side-by-side comparison of why I think this will work. By looking at a profile shot of both of the rudders, it's pretty obvious that the triangular rudder will probably be less efficient if you want to go for speed. However, I'm going to be using this hovercraft mostly indoors, so I'd rather not crash into things at high speed. From this profile shot, it's pretty clear that the angle of the air leaving the triangular rudder is much greater than the angle of the air leaving the straight rudder. The air leaving the triangular rudder is almost at 90 degrees from the original airflow direction, so I'm hoping that this will increase the control authority. After only a few seconds, I realised that the new rudder was a huge improvement. I was able to turn the hovercraft in one direction and then reverse it, turning the other way. I also realised that it helped to keep the throttle at a constant setting. This meant that the steering rate was constant as long as I didn't change the throttle. I even went as far as setting up a figure of 8 drift course using a paper roll and a bit of tape. However, if you choose to use a paper roll, make sure you have someone to blame for the mess. So that sums up this week's video. I'd like to thank you very much for watching. Please leave a thumbs up if you enjoyed this video and subscribe if you're new to my channel. A huge thanks to all of my patrons for supporting me. You guys make these weekly videos possible, and you'll be getting access to the 3D printer files of this hovercraft next week when I come out with the version 2. So stay tuned and I'll see you next week. Goodbye.